Hello and welcome to this second part on the course on Introduction to Scientific Programming and Machine Learning with Julia. So in the first part we did look on classical elements of the programming language Julia, so we learned a lot about it. And here we start instead to look on libraries that are more of a direct interest for a scientific context. And in particular, in this first segment of this second part, we will deal with data analysis, how to handle data, and for the most part, we'll use data frames package. So as the first things, we start doing what we learned to do on each segment, that is it, to start and run a few line of code to activate the environment. So I recall you that each part has its own environment. So for example, 0201 has the same environment as 0202, but is a different one than the environment used in the first lesson. And as here is the first segment of the part, we also put attention to instantiate the environment so that we have available all the packages that we will use in the second part. So as I said, we will deal in this segment mainly with data frames, but what are data frames? Well, if you know Python or R, they are very similar to Python pandas or R data frames. That is it, format to host tabular data, and in particular in memory tabular data. So the data is loaded in memory. And why are we using them? We said all the time that arrays in Julia are efficient, so why not just use a matrix? Well, we have two main advantages using data frames. The first one is that there are sort of matrices where each column can have a different type, so the information of the type is stored in the data frame. So each column can have a different type, and still the data frame remain efficient, contrary to a matrix where if you have different types in different cells, not necessarily on different columns, you end up with a matrix of type any, and that is not very efficient and fast. So this is the first reasons, and you will see that the column, differently from the other packages, similar packages in Python or R, the column of data frames are actually some basic wrapper to arrays. So it's nice because all what we learned before on arrays will apply to data frames columns that are nothing else than arrays. But the second nice things of data frames is that they provide a consistent and useful API to work with this data. The columns have names, and we have an API to indexing, to querying the data, to join in different data frames, and to apply what is called split apply combine workflow that we'll see is very powerful. So this is why if you work with in-memory data, in-memory tabular data, most likely you will use data frames. The name of this column can be either expressed as a string or as a symbol. Here is one example with the column. So this is the same most of the times. So we are going just to use string for simplicity, so you can forget now what a symbol is. Let's start with import of the data. Which are the different way we can have our data available for the analysis. Julia itself has built in the possibility to read comma-separated values and read them in a matrix, and to do that we use delimited files. So here in the repository of this course, there are some data that I took from Eurostar, and because I work with forest, these data are also about forest volumes and forest area. So we have this data in a comma-separated value, and you can see that you can use this delimited files library in the standard lib and use readdlm, and the results is in a matrix. However, here we specify a range starting from the first row and the first two columns, because we want to have a matrix of floats. If we didn't specify this one and we didn't explicitly converted, we would ended up with a matrix of any. So this is the problem again of matrices. We cannot have the headers that are typically strings or integers, and the data that may be floats together. We will end up with a matrix of any. So here is why I'm skipping the headers, and I'm taking only the data, and I'm explicitly converting them to float. So if we want to get instead the data frames, we need to use a dedicated package that is data frames, and to load the data we have from CSV. We have the package called CSV, csv.gl, and this has the opportunity to load the data and load it in different what is called sync. So the syntax is csv.read, then you have to specify the file you are reading. The sync here will be data frames, and here will be another one, a named tuple, for example. And then there are a really lot of options that you can give to CSV read. And here I listed some of them, for example, which is the missing string, which is the decimal character, which is the separator, and so on. You see them, most of them here. So here I read on a data frame. Here I get them on a named tuple, and here if I want for some reason to have the data, don't do that. It's very ugly, but it's really very ugly. But if you want put, for some reason you have to put your data directly in the script of that you are using to elaborate the data itself. You can do that with using the input-output buffer, and this is the syntax. If you have your data in Excel, the package that you will want to use is XLSX. So here we use it. If you don't know if you already know your file and the name of the sheets, you can use these functions here. If you do not know, if it's too big, you cannot open, or you don't have Excel on your computer, you can get the sheet names using this call here, where you read and the data, and you call the function sheet names, and here you have a vector of the sheet names. Using this information, you can read the data by specifying the file, the name of the sheets and the range where you want. Again, here you will have a matrix of any, or here to say you want to read all the data at that specific sheet names. And another way is using read data. So these are equivalent. All these read the data in form of a matrix. If you want a data frame, you can use this read table syntax here, and this returns a tuple vector of on one side data vectors and another side vector of symbols. So the output is a tuple, and the tuple has two elements. The first element is itself a vector of the data, that are vector again, and the second element of this tuple is the vector of symbols. Why this strange output? Well, because this strange output is one of the ways that you can have to construct then a data frame. So you read the data like that, and you use this one to create a data frame. So this is a data frame constructor, and you end up here with the data frame. If your data is in an open document spreadsheet format, you can use ODS.io and specific but the return type. So here you use ODS_read, the file name, the sheet name, and the return type. And you can also give, so the return type can be a data frame or can be a matrix. And in both cases, I didn't put it here, I put it just here, but you can also specify that instead to read the whole sheet, you get some specific range that is a vector of two tuples. In the first one, you specify the top left right, and so here the top left right is 2, and the top left row is 2, and the top left column is 3. So this is C2 basically, the cell C2, and here is the same for the bottom right row and bottom right column. So this is A, B, C, D, D9. Between C2 and D9. Then sometimes your data is on the internet, is not on your local machine, so we can get them directly from the internet without storing them in a temporary file. And to do that, we use to download from internet, we use the package HTTP. I importing here instead of using, because otherwise HTTP has some method that would conflict with others. So I'm just importing the package, and then I'm calling the package function with the full name. So we use one. There are many ways you can do that, but one I like particularly is the approach that I'm presenting here, because you pipe the data between, and you have the different step between importing and processing. And so you download, you process the data according to your needs, and then you import it through a data frame. You see here that I just, to show you, I replace the semicolon here with a space, and then I call here the delimiter to be a space. And it may take a little bit of time the first time, but this is really nice because sometimes you have to do something before importing in the data frame, and this is how to do it. So here we have our data, where we first get it, the body, we pipe it to the replace functions, and we pipe the output to the import CSV import, and we pipe the output to data frame. Sometimes your files are CSV file is zipped, so why not use the same method to unzip the data and import it? And here it is. Still we're using pipe. We can use zip file package to read the file, read the archive, sorry, and we assuming here that the archive is made only one file, so we take the first file of the unzipped in memory file. So here we are not saving to disk anywhere, it all happens in memory. We read, extract, and get the first file, and then we pass this file to CSV, and then the CSV will parse and transform it to a data frame. Of course, we can also do the two things together. So here is an example using the same general methodology to get something from internet, unzip and parse it to a data frame. Here we use explicitly the input-output buffer. Okay, so all this case we have the same results. We can also build our data frame directly using the constructor. So one constructor, you already saw it, it was here when I told you that one constructor is a tuple of where the first element is a vector of the data and the second element is a vector of the symbols that will be used as headers, as a column name. Another constructor here is directly to provide the column name with the data on each column. So here we construct our data frame. Sometimes you want to import from a matrix, so here we have our matrix, and here we have our headers, and here we import we use the constructor that we saw for using from Excel SX, the tuple of the vector of data and the vector of symbols, from which we take the data from these two elements, from the matrix and the headers, and we construct here the data frame. Sometimes the data and the headers are on two separate objects. Sometimes you just have a big matrix where the headers are on the first row, and this just a adaptation of this method here, but the constructor is exactly the same, and we end up with the data frame.